Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Gobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 2. It says A to F in the table below represent 6 organic compounds. And then we know what we should do first is to analyze where each and every organic compound here belongs, right? So which homologous series does each organic compound belong in? Then A, we can see that because of the bromo, this belongs in the haloalkane homologous series. And then B, because of the triple bond, we can see that this belongs in the alkyne homologous series. And then C, because of the double bond oxygen in the first carbon, this is the formal group, so we know that it belongs in the aldehyde homologous series. And then looking at D, we can see that the double bond oxygen now is in between other carbon atoms, so this makes it a ketone. So that's a carbonyl group. And then E, because we can see the Cu here, and then that's carboxyl group, we know that this belongs in the carboxylic acid homologous series. And then F, looking at the OH here, we can see that this belongs in the alcohol homologous series. So pretty much interesting. All the homologous series here are different. Then 2.1.1 says letters that represent 2 organic compounds that are isomers of each other. Now, if we can see that all these organic compounds belong in different homologous series, we know that for sure we cannot have chain isomers, and then we cannot have positional isomers, because with chain and positional isomers, it has to be compounds that are in the same homologous series. So that means that leaves us with one isomer, which is the functional isomer, right? The functional isomer, we know that the compounds can belong in different homologous series as long as they have the same molecular formula. So this is where we get to use cake. So always remind yourself of this cake, where we say the carboxylic acid is a functional isomer to the ester, and the aldehyde is a functional isomer to the ketone. Now looking at this, we can say that the carboxylic acid does not have an ester here. So that means we cannot find its functional isomer. But let's look at aldehyde. Can see that it goes with ketone, and this is perfect. Look, 1, 2, 3, 4. Also here, how many carbon atoms? 1, 2, 3, 4. So we already know that the molecular formula will be the same. And then these are functional isomers. So we are supposed to indicate the letters, so that's C and D. Now in 2.1.3, they're asking type of isomers, chain, functional, or positional. We already know it's functional, right? Because they belong in different homologous series, but they have the same molecular formula and different functional groups. Then 2.1.3, the general formula of the homologous series to which compound B belongs. We've already identified that compound B is an alkyne. So the general formula for alkynes is CnH2n-2. Right. Then 2.2 says, write down the IUPAC name of compound A. Right. So let's indicate 2.2.1. To write down the IUPAC name for compound A, let's locate compound A here and identify its longest chain. So if we can go 1, 2, 3, 4, 5. Okay, let's go 1, 2, 3, 4, 5, 6. So we can see that the longest chain has to be this one, forming some kind of a zigzag shape here. And then this is our longest chain here. So always confirm your longest chain, because what you think might be the longest chain might prove not to be the longest chain. Now, looking at this, there's an important rule that we need to discover here. Counting from this side, we have 1, 2, 3, and then we are met with 2 methyl branches. But then counting from this side, we have 1, 2, 3, and we are met with a bromine or a halogen, right? Now, this is a question of which one has first preference. Is it the methyl branches or is it the bromine, the halogen? So note the rule here. Note the rule NB. The rule says the alkyl groups will have first preference over the halogens. So in a case whereby when you number from either sides, your halogens and your alkyl groups are in the same position, then you have to start numbering from the side where you see the alkyl groups. That's basically what it means. So this is a rule for numbering, right? So in a case whereby when you number from either side, you have your alkyl groups and your halogens in the same position, then you have to start numbering from the side where you see your alkyl group. So that means it's 1. So let me indicate with a clear color. So that means I will start 1, 2, 3, 4, 5, 6. Now this makes your bromine to be in the 4th position. And then having to name this. Now, remember, when it comes to naming, I have to follow the alphabetical order rule. So as much as I decided to count from the number where I see the methyl branches, but then in naming, I'm still considering the fact that bromo B comes before M methyl. So I need to name this 4-bromo and then hyphen. In carbon number 3, there are methyl branches, so that's 3,3-dimethyl. But then what is our longest chain? That's 1, 2, 3, 4, 5, 6. So it is supposed to be hexane. So 4-bromo 3,3-dimethyl hexane. Note that. Right. So as much as I decided to number from this, but then when it comes to naming, I must follow alphabetical order rule. So you note this, you note that rule there that we have discovered. Make sure that you know this rule here. Okay, now let's go to compound B, which again we will discover a very important rule. Now when it comes to B, we have 1, 2, 3, 4, and then let's name from this side. Let's number from this side 1, 2, 3, 4, 5. So we can say that our longest chain can be this straight chain here. So this straight chain here can give us the longest chain, right? But then look at this once again. If we number from either side, this is 1, 2, we are met with a triple bond. But then from this side, this is 1, 2, we are met with what? Methyl branches. Now, what is the rule when it comes to this one? Do not be confused now. The alkyl groups can no longer win against the triple bonds. So the rule, another rule that you need to note is that the functional group, which in this case is the triple bond, will have first preference. Over the alkyl groups. Okay, so that's all you need to note there. The alkyl groups can win over the halogens, but they cannot win over the bonds, right? So that means I will start numbering from the side where I see the triple bond. So that's 1, 2, 3, 4, and then 5, right? So now, what is the name? The IUPAC name. Remember, I'm still looking for the IUPAC name. So this will become what? 4, 4, and then dimethyl, because now our methyl branches, if we start numbering from here, they're now in carbon number 4. Dimethyl, and then longest chain is 5, so that's pent, but then that's a triple bond, and then in position number 2, so pent 2 wine, right? So 4,4 dimethyl pent 2 wine. So the pent for 5 carbon atoms. right? Then that's how you were supposed to indicate that. Then note the important rule that we discovered again here. The important rule that we discovered, that the functional group or the triple or double bonds will always have a first preference over the alkyl groups. Then 2.2.3, compound C. Compound C. Now, compound C is an easy one. You can even see the 2 marks. This is 1, 2, 3, 4, right? And then remember, with an aldehyde, there is no positioning of the functional group, because the functional group will always be on the first carbon. So all you have to do is count the number of carbon atoms. There are 4. So that means your compound C for 2.2.3, we have what? Butanol. So just like that, 4 carbon atoms, that's but. So this is butanol. And then, okay, we are done with the IUPAC names. Done with the IUPAC names. Let's proceed to 2.3. 2.3 says compound F. Compound F reacts with a carboxylic acid to form compound S. So compound F, where do we see compound F? We said compound F is an alcohol. It reacts with a carboxylic acid. Now we already know what's going on. If we have an alcohol reacting with a carboxylic acid, we know that these two are about to form what? An ester, right? So these two are about to form an ester. 2.3.1 says, write down the type of reaction that takes place. Now, the type of reaction that takes place is esterification. This is the reaction that forms an ester. So esterification. Then compound S is an empirical formula of a C3H6O and a molecular mass of 116 gram per mole. Write down the molecular formula of the carboxylic acid. So at this point, you can see that they've already done the empirical formula for you. So all you need to do is take the process further by just calculating the molar mass of the empirical formula, which is C3 and then H6 and then O. So there are 3 carbon, but then your carbon is 12, and then 6 hydrogens, and then it has a molar mass of 1, and then 1 oxygen, which has a molar mass of 16. Now you need to punch all that into your calculator. 3 multiplied by 12 plus 6 plus 16. This gives us 58 grams per mole, right? Now, what should you do at this point? You take the molecular mass of the molecular formula, and then you divide it by the molar mass of the empirical formula. So 116 divided by 58, it gives you 2. Now, what you should do with this 2 is multiply it to the empirical formula so that you have the molecular formula. So the molecular formula will now be, molecular formula is now 3 multiplied by 2, that's C6, and then 6 multiplied by 2, that's H12, and then 1 multiplied by 2, that's O2. So there you go, you have your molecular formula just like that. And if you want to confirm if you are correct, you can just calculate the molecular mass and see if it's going to give you 116 gram per mole. And then in that way, you will confirm that you are correct. Right. And then that's how we were supposed to tackle this question for a total of 15 marks. So please repeat the video as many times as possible and just make sure that you pause and try to understand the approach that I took here. But then with all that being said, we've come to the end of the lesson. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.